Okay, so just now I was saying that you have the function generator. Okay, it can generate. Why we call it function? It refers to the math function. Okay, you use the math function, you can generate square wave, sine wave, and triangular wave. So later on in the Tinkercad, you will insert this one, and you set the parameter amplitude to 10 volt, DC offset, and so on. Okay, and the oscilloscope is used to measure the. This is the oscilloscope. Okay, it's used to measure the function generator output. Okay, so can you tell that this oscilloscope here, the red color and the black color, is measuring the function generator output? So what you can do is to tell that you can trace the red wire, right? You see, you look at the red wire, you go this way, go to the copper thread, and then is connected to the function generator positive terminal. And then the black wire, if you trace along here, you will go here, okay? Because these 5 holes, they are connected, right? And then finally, the black cable is measuring the negative terminal of the function generator. Okay. So now let's launch the Tinkercad. Okay. So you click here to create, correct? Create circuit. Okay, create and then circuit. Right. Then you create the circuit. Okay, let me see whether you are. Can you show me that you have your so you just draw the Tinkercad as shown in the backspace. Okay, so you first of all, okay, the blackboard, correct? Blackboard. You can choose the small one for this one. Okay, it's good enough. Then you have the function generator. Okay, function generator. So you place it. Okay, and then you have the oscilloscope. Okay, something like that. Then how to fit the diagram nicely into the workspace? Okay, is this icon here, correct? Okay, zoom to fit. Click on this icon. Okay. Okay, so how to set the function? How to set the values in the function generator? You also know, so you just click. So you set accordingly. The amplitude is 10 volt. Okay. And amplitude 10 volt, DC offset 0 volt, frequency 50 hertz. Right. DC offset 0 volt. Okay. Okay, you just set this on. Right, so you have 50, 10, 0, and sine wave. Okay, you can refer to this one. Okay, set all these things. It's highlighted in the yellow here. Actually, you can see from here also all the setting here. 50 Hertz, 10 volt, DC offset. Okay, class. So if you look at this, can you pause a while? So you look at this oscilloscope, how many cycles are there? From here to here is 1 line, then 2, 3, 3.5. So it's not 2 cycles. So you can set the permission, okay? You just click on the oscilloscope to set the time per division. Say, let's say you put 5, then you see less cycle. So you can see when you make the time smaller, you will get the fewer numbers of cycles. And take note, for oscilloscope, you don't have to stop simulation, right? You don't have to stop simulation. Straight away, you can see the effect. Okay, so you can try and error lah. So you send it to 7, then you see fewer cycle. Okay, this is one way to display 2 cycles. Another way is you go and calculate or do some calculation, and then you will know how many milliseconds you want. So and take note, oscilloscope, you don't have to stop simulation. Straight away, you can set the time per division. So you will see something like that. Okay, you will see something like that. Right. You see something like that, 2 cycles. Your time rate might be shifted a bit, but as long as you have 2 cycles, it's okay. Or the time rate can be shifted to the left or right, but still can have exactly 2 cycles. This note is not the Tinker cap note. Okay, no need to put the note there. Yeah. Don't bother about this question. Just look at this one. 2 sine wave, 2 cycle. What screenshot? What one? Oh. If you want, it's okay. Optional. Put your name now. Or your name. Put your name. Okay. This one is optional. This one is just a comment for me. You don't bother. So you can see from here lah. So let's say you set the time per division very small. You will see, wow, all the time we came together. And the first question, do you know how to answer? Okay, so what is the answer for this one, class? The amplitude of the function generator we have set to 10 volt, right? So now you refer to the oscilloscope. Okay, refer to the oscilloscope. Number 2, what? Let's see whether it's number 2 or what. So if you have done correctly, you have something like that, right? Okay. So now based on the oscilloscope, from peak to peak, how many volts? This one important. You must know how to read the oscilloscope. So over here, do you see 20 volt here? Okay, how come the it doesn't matter. Okay, so you can see 20 volt here means from here all the way to that, to the one. Okay, so one division is how many volt? One division is how many volt? So how many divisions are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So you have 20 volt and 10 division. So 1 division is how many? It's 2 volt. So now you look at the timeline here. From here to here, how many division? This is 1. This is 1, 2, 3, 4. Then this one half. The other side half. Right. So altogether there are 5 division. Oh. So 5 division, how many volt? Okay, simple mathematics. So you okay lah. I think first one better get the answer right, otherwise all wrong. Okay. So multiply by 5, so you get 10 volt. Okay. So the question, come back to this question, which is important for your question 2 also. Coming back to this one, this is the answer. 10 volt refer to the peak to peak value. So when you set the amplitude of the function generator, when you set it to 10 volt, this 10 volt means 10 volt peak to peak. This understanding is important for question 2. Okay. So this answer. Okay, and then class, if you do question B, this is a formula. V peak equal to VRMS divided by 0.707. This is the formula. And I just posted a message in your MS team. Do you see this one? Your tutorial 6 question 3. Okay, you can take a look at this one. Okay. So this one, this graph is very similar to your oscilloscope, right? So you can take a look. It's a tutorial, and then the solution is here. That means given this graph, you are asked what is the peak value. The peak value is 25 volt, right? Peak value is a positive right here, 25 volt. Then you peak to peak, okay, and then RMS value is 0.707 multiplied by this one. This is a formula, formula. So yeah. So yeah, you can do. I show this one for you so that you can do. So the formula is here. Okay, RMS can apply to voltage, and also the RMS also can apply to current.
What do you see expect everything?
，Okay, so if you want, you can take a photo of this. And you can refer to this thing here, this thing here, or you can refer to the tutorial next question 3, which you can find in the MSC message. This one is it? This one is only submit the screenshot. What document is for you to put your screenshots only? Only 2 screenshots in the Microsoft Word document. And this one important formula, remember it, okay? Okay, because I think most of you have done this part already. Okay, so I just want to explain some theory. Power, okay, for AC circuit, power is V RMS squared divided by R. Okay, if you recall what you studied in DC circuit, power is V squared over R. So basically the concept still apply. The only thing is because the AC, the voltage is a sine wave, so you must always remember to convert to the RMS value to calculate power. So same thing, for DC circuit, you have three formula for power, right? Can you remember what is that? I squared R, right? Okay, then you have IV, right? So over here is the same. You have I, you must convert it to RMS for AC circuit. Okay, square multiplied by R. Okay. Then over here also the same. I RMS multiplied by V RMS. Okay. So this is the theory. And next thing I want to highlight to you, when you see an AC source like that, and then you say the question say, hey, the AC source is 110 at 110 the angle 0 degree. This value is always RMS. Okay, how to remember is RMS. The reason is it's very important to calculate power. That's why we always give the people we always give people the RMS value instead of the peak value. Why power is important? Because based on the power, you can calculate the energy consumption. Then you can calculate the electrical bill, money. This is where the people need to spend to buy the energy from the electrical supplier. So okay, and please go and substitute the values. If you don't substitute values straight away, give me like that, you are just merely copying. Already very good already. I give you the answer to verify. So please substitute the values. If you don't substitute the values, marks will be deducted. That means you have to show what is the values here. Okay, show the write down the values here, then you give the answer. And remember, yeah, so this one is the spin slot, okay? Exactly 2 cycle, okay?
Yeah, I saw, but it's correct, man. Because you really have
Okay, so you can proceed to do question 2. Okay, this is a slide for question 2. Okay, for question 2, you may duplicate a copy of your Q1 circuit and then modify the new copy for Q2. So let me show you how to duplicate it. What you can do is you go to the Tinkercad, go to the higher level in the Tinkercad, and then you see this you see this one. Okay, do you see the gear here? So you just select the duplicate. Okay, so you click on the gear, or click on the gear. Step 1, click on the gear. Step 2, select duplicate. Then you will duplicate the circuit. Okay. So the duplicated new copy, you can use it for your question 2, and you leave your original copy untouched. In case you need to go back to question 1.
Wait, I don't
Yeah, go to the higher level. Go to the higher level. Then you identify the circuit. There's a gear. Okay, go to the Google. Yeah, then there's a gear now. Okay, so so this step number 1 here is a gear. Okay, there's a gear. You click on the gear, then duplicate. Okay, I paste this screenshot in the MST message. In case I should short the screen, you can refer to this. Okay, so yeah.
You haven't oh my those were I like those were here you go.
Okay, so for question 2, you're supposed to use the oscillator to measure the capacitor voltage. So very simple. Positive terminal of the oscilloscope, you connect to one leg of the capacitor, then the negative terminal connect to the other leg of the capacitor. So you have the capacitor voltage. And the frequency of the function generator, okay, you have to calculate. The question tells you 10 milliseconds period. So frequency is 1 period. Okay, by the way, when mini project come they might not give you so many instructions. So for example, the finger circuit, the best is you can connect yourself. I don't know how is the question like, but basically it's single cat, and then after that you have to show me during the mini project, just like this one, you show me your single cat oscilloscope, and you also have to submit. It's written there. Okay. Later on, after the lab, you have time, you go to backspace, you can read the instruction there regarding this project, mini project. Yes.
We can do this, but we use the
No, someone important for I think you get physics and you say the everything is the deep right. But for single cat function generator, it's like that often you need to know. Okay, maybe I highlight the function generator. Okay. So everything of the function generator. Okay, it's good that you Google. It shows that you have your initiative to learn yourself. Very good. Okay. So some students go and Google. They say, hey, amplitude is V peak only. It's not V peak to peak. But for Tinkercad function generator, I mean, when you set the amplitude of the Tinkercad function generator, the amplitude is peak to peak. That's why you did the first question, right? The first question, is to, you see, 10 volt, the amplitude of the function generator when you set to 10 volt is actually peak to peak, not peak value. So in this case, you have to set accordingly. So this one, how many hertz do you get? I will show it's 1,000, 1,000 or 100. I know some of the class tell me 100, 100 hertz.
Big value. What do you mean 2.5? Because for actually right now.
Okay, so your capacitor voltage waveform should be something like that, just to help you all. Okay. Okay, class, this one, if you want, you can take a photo. This one is a capacitor voltage waveform. 2 cycle, exactly 2 cycle, not 2.5 cycle or what.
Everybody else is you change this? And all my stuff. I didn't even see this.
It's a measure one.
Yellow color. Always know like the ones
Aku tak gitu lah, orang yang jual. Tapi dari memang tu kan, shred.
How you get that? That one. You still look at your nose. What's the same one? You expect
Jangan dibayar sedikit.
Okay, if you are doing part D, 2D and 2E, you can read this one. It's similar to the backspace, but this one is more organized up. Okay. Okay, can you pause? So I will explain this one. You have to calculate the magnitude of the impedance. So to calculate the impedance, which involves resistance and the capacitor. Okay. This one we learned in the tutorial, right? Last tutorial. Z equal to R minus JSC. Okay, this one. Okay, Z equal to minus JSC. And then okay, then XC is 1 over 2 pi FC. You substitute already, you should get this 1591.5 ohm. And how do you calculate the magnitude of the impedance? You can use calculator to convert the rectangular form. This is the rectangular form, right? Convert to polar form, then you will get the magnitude. So how to use a calculator? I have a message. Okay, I have a message inside the MS Team earlier here, right? So for example, 10 plus J20. This is rectangular. How do you convert it to polar? So if you using this calculator, you do this. If you're using the sharp, then you do this. Okay. Then the second slide, maybe so far you don't use that. I mean, convert polar to rectangle. So far you all don't use. So the first one, so you can refer to this one. If you want to use calculator, if you do not want to use calculator, okay, then where is it? Okay, so if you do not want to use calculator, the magnitude can be calculated in this way. So this is the alternative method. Then finally, you are asked to calculate the RMS value of the capacitor voltage and the resistor voltage. Okay, so let's look at the resistor voltage first. Ohm's law still apply. You get the current RMS multiplied by the resistance. This is the Ohm's law, right? You look at this series circuit. Imagine there's a current flowing here. So you get the current multiplied by resistance. Right? Current multiplied by resistance, you will get the voltage. And how do you calculate the current? Ohm's law still apply. Right? I equal to V divided by, for AC circuit, you use Z, correct? Z you have already calculated here. Okay. So now you substitute I RMS equal to this, substitute into here, correct? Okay, this I, you substitute this one, correct? You substitute this one here. So you have this one. So far is it okay? Then for capacitor, similar to Ohm's law, basically you get the current multiplied by XC. Then you same thing, this current you substitute by this V divided by Z. Okay, then you get the voltage. This theory is written in the backspace also, okay? At the beginning part of the flat tree in the backspace. So if you want, you can take a photo.
Yeah, but capacitor is it many degree? Many degree machine. When he on top.
Yeah, sorry. Going on. Check out your stations.
This is the first one still.
Oh, still the first one.
The whole second one is.
Standing the festival here. What's the Lama Village? I'm saying that.
Okay, so one. Very bad.
What that? Which citizens are you from? I also don't know. I don't do it. Just do it once step. And so now we will start this one.
Do screenshot. You press the pen screen key off. Or you use the snipper. Ah, okay. You run first.
It doesn't work. Oh, there's nothing. It's because I never put frequency. What's the frequency? I don't even know what's the frequency. 100. Don't have it. Only the box is wrong. That's how they say the box is 3.
You didn't connect.
Why we never connect?
The resistor, this leg, where do you connect to?
Oh, it's connected here what? No.
Edit and redo lah.
Oh, the phone has
And we do
stop.
record.
Phone has stop.
Are you sure this leg is connected to the black wire?
Yeah. Wait, it's not.
So it's.
Wait.
Minus
Just give me a bit of time. Go like this. Okay.
Okay, you connect like that very strange, huh? You must understand all these things. Okay, can you delete away this delete away this wires? Okay, you must understand the blackboard. The blackboard here, all these holes are this back part. Do you see the this one? All the holes are connected. This one, only this 5 hole. One, behind there, there's one lah. Behind that, there's 1, 2, 3, 4, 5 are connected. Yeah, so you like that connect. Okay, yeah. Or you connect here, then and this one you connect here. Okay.
One more down.
Yeah, or you connect like that, then another wire connect like that. Okay. You have to understand that. Otherwise, really forget, you might have problem. Okay.
Yeah, I think it's just the number.
Okay.
I don't know which one.
What? Now you want to you want to display 2 cycles, is it? So is the oscilloscope click on the oscilloscope. Okay. Play around with this one. The numbers will be smaller. If you want to display less number of cycles, the numbers will be smaller and smaller. Yeah. Okay. Yeah. The screenshot for capacitor, yeah. Then the let's say also ask you to measure the capacitor voltage, right? So based on this one, you must answer how many voltage is it. Okay. There's a question that asks you to measure the capacitor voltage by referring to the oscilloscope, right? Yeah, so you display 2 cycles already, then based on the oscilloscope, what is the peak value of the capacitor voltage?
How do I find the capacitor?
No, This one is ask you to look at the oscilloscope and give the answer. It didn't ask you to do the calculation. It asks you to use the based on the oscilloscope to find out. You know how to do?
No.
Huh?
No.
No. I just now I explained, you didn't listen. You so just now I explained this thing. So now I explain this one, right? So how to, like for example, from here to here, how many volts? You look at here, around one division, right? Okay.
Okay.
Okay, you look at this one, one division, right? Then two division, then this one maybe half. So the question asks you peak voltage, right? Peak voltage from here to here, right? So 2.5 division is how many volts? You have to look at the scale here. Okay. So over here it says 20 volt is everything. So everything is how many division? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. 10 division. So just now I explained already. 20 volt, there are 10 divisions. So one division is 2 volt. I mean, based on this example, based on yours, you have to do your own calculation. Okay. Now we come back to the your oscilloscope have to connect with the capacitor to measure the voltage. One leg, and the other connects and connects to the other.
If you use it for value of convert into a value.
Yeah, but it's produced. Okay, so
I didn't know.
Yes. Yeah. So and then the other
you change it to two different. You change to one like I don't
so is
Wait, you don't change It's like edging those lines. Looks like edging and choosing. Not my sketch. Yeah, right. I see that.
Oh, I must say it was very funny, right? Right. It's very popular. So, it's very.
That's good.
I don't know, but.
When you play a ball, that's basically what are you doing? Oh, sometimes
Should look at my account, so I guess.
no, I don't.
Oh, yeah, it's so easy to ball, so you have. I think this.
Is that the column? It will be right.
1,239.6 single negative 47.9. Angle.
Okay, just sometimes the Tinker circuit doesn't give you the expect values. You have to stop simulation and start simulation. Okay, a few students have this issue. Oh, yeah. If you suspect the Tinkercad has some issues, you stop simulation and then start simulation.
Oh my God, it's actually one of these,
The one with the one
I think the same thing what you say. But it's a way very much. Tiger first. It's called Tiger's price.
They also ask for 2 cycles, right? I think it's written in the. What cycles because 2B says 2 cycles. Question 2B stated 2 cycles. Okay, so both screenshots you display exactly 2 cycles.
The angle is just to show how much. Mine correct. Oh, wait, there's mine is nano. So it's correct. Thanks for if you got 45 meters per person, you really have to jump. What am I? What do you want? This is the voltage. Just the lead for 6 not do right. The voltage of the resistor. Why not? And you find it, and it's value find it. Right. So how do you promote the name for the
What? Itachi. What would you
Yeah, I see you can go to my YouTube. My days, bro. I'm gonna look for hot bro. They open my YouTube. They're gonna think I'm retarded.
It's a black guy playing game.
Oh my day.
Maybe a black guy.
Oh my day. I don't play Fortnite.
I'm also got
Street.
every single time they just fucking.
I think I lost
Because I in the next thing. Yeah, one enough is and you guys have been like, I think it's
Belroy. Yes, yes. We don't want to sell time. Yes.
Oh, guy.
Is the world.
It's just me, yes.
See is the result of performance.
Okay. Just now, when you all want to make it 2 cycle, you all try and error by setting the time per division, right? So if you want to do calculation, you can do this method. Okay. This is for question 1. Or question 1. You want to have exactly 2 cycle, right? So this is how you calculate. Question 1, the frequency is 50 hertz. Right. This is question 1. So in the end, you set 4 milliseconds.
What? You know they say either one, right?
Okay, class. Also remember to submit your screenshot. So it should be inside a document like that. So if I open up, I should see 2 screenshots inside. Okay, so if I finish, you can read this one regarding your mini project. Okay, when is it? Just now I showed you that your mini project is here. 3 weeks later. This week we are here at this week. So 3 weeks later you have the mini project. And also this week you can do this one already. Yeah, I think you all have to just remind you. You have this combined quiz. You all can do already. Marks are awarded. This is a combined quiz. Okay, so if you are done, please remember to submit the screenshot to be inside the Microsoft Word document. You submit the Microsoft Word document. And if you are finished, you can submit and then you can leave the classroom. Is there any student who need to take retest? For the common test retest, okay? When is the retest is announced in the black space already, the common test retest. Okay. Yeah. Okay, so if you have done it, you submit to the front and then you may leave the classroom. Other students, you have any question, you also can ask me. TK10. Okay, class, if you have forgotten your serial number, you can refer to this one. Your serial number. And is there any student taking retest? TK10. Oh, I didn't do the things. Okay. So if you have submitted, okay, make sure that you have submitted your screenshot also. Then you may leave the classroom.
This one go to like a PPT. Not videos. Not PPT.
That's what I mentioned already. It's different. It's like that because when on the function generator, okay, if you set amplitude, it's click to click. That's why we ask you this question. You're saying that why the amplitude is not click value, right?
Yeah.
For function generator somehow is different. So that's why we ask you this question so that you can do this one correctly. Okay.
Alright.
So I was a bit hard to understand because I thought so in AC TK, right? The voltage of each component doesn't equal to each other, right?
Voltage of each component not equal to each other.
The source.
No.
It's not equal. Like the voltage.
It will distribute in 2 components.
Yeah. No. Wait, so then you can just take the voltage of
Multiply by the reactance. Actually, to be to be more accurate, you have to multiply using the contact number. Just now, for example, I say this right. This one not in the over here, AI multiplied by SD, right? So you should actually this one is you are getting the magnitude only without the angle, right? So actually is you should use the real one, right? To use the compact number. This one should be the compact number. All this must be compact number.
What's my serial number again?
I mean this part here, it will become for example this one it's JNB, right? So it's actually multiplied by minus 8. Then you will have the angle 90 degrees. Okay. But in the scope of this module, we can just talk about the magnitude only. Actually, it's multiplied by the compact multiply using compact number. Current also compact number. Yeah.
Check
What serial number?
Yeah.
Serial number?
What's that?
Okay, class, this is your serial number.
Actually, again, put 19.
Huh?
I know.
19, you take your left sheet and what? You have any question or not? You pass with your common test, right? Yes. Okay. But you have any question you can ask.
We need to right. Plus, no, ask them. What's my name? I also need to find what the
There you go.
19.
Oh, this one.
Oh, I'm saying this.
Huh?
I'm saying this.
No need.
Not yet.
Just a second. I guess it 14.
Oh yeah, right.
No, why you just yeah, yes. Yes, I said he's doing it. All the companies. Let's study the value. The last one right now.
So just please. Yeah. Yes.
Number 5. Next number, I think.
Five, is it?
Yeah.
I might be go back. I wrote something wrong.
Yeah.
Okay, yeah.
I think that we cycle 3, which is about half on the place.